Yeah, hi. I took 2 days ago a screenshot, and there was quite some action going on around the Alps, and you cannot see it, but here's the volcano. Unconfirmed 3.8, 20 kilometers in depth, which is really interesting beside a volcano. And it's the River Rhine which is going there through. And yeah, I want to read a quick thing about the sun and then we come back to Earth. So that's SciTech Daily from some time, summer last year. Take an unprecedented look into central engine powering a massive solar flare. New Jersey Institute of Technology. Note Earth to scale. So this is how it looks. Observation of a large solar flare on September 10th in 2007 in extreme ultraviolet grayscale background by NASA Solar Dynamics Observatory and microwave. Red to blue indicate increasing frequencies observed by the expanded Owens Valley Solar Array. Light orange curves are selected magnetic field lines from the matching theoretical solar eruptive flare model. The flare is driven by the eruption of a twisted magnetic flux rope illustrated by a bundle of color curves. Microwave sources are observed throughout the central region where a large-scale reconnection current sheet, the flare central engine, is located and are used to measure its physical properties. So that's quite a big structure what we have here, and I was being a little bit artistic. I made a picture. Ta-da, here it is. So now this is the Eiffel Volcano Complex. It's a little bit more far north than the other one. We have Campi Flegrei in Italy and the Alps and the Jura Mountains in the middle. And somehow this setup matches in a way quite well with what happened on the Sun. And if we check out the timelines, which we do now, by going to Volcano Discovery, check it out. Last eruption 10,900 BC, 9,191 BC. Okay, 12,000 years approximately. And then let's go to Campi Flegrei. Yeah, it has erupted many times, but it had also in this time period about roughly 12,000 years. So they were active at the same time. Which doesn't mean that there wouldn't have been any other volcanoes active at the same time. And there's another article. I hope I find it quickly, because I forgot about it. I just remember it now. If I don't find it, we don't talk about it. Found it. Textbooks and geoscientists may be wrong about how the Alps were formed last year. ETH researchers have used a computer model to test a new hypothesis about the formation of the Alps while simulating seismic activity in Switzerland. This will help improve current earthquake risk models. For a long time, geoscientists have assumed that the Alps were formed when the Adriatic plate from the south collided with the Eurasian plate in the north. According to the textbooks, the Adriatic plate behaved like a bulldozer, thrusting rock material up in front, up into piles that formed the mountains. A few years ago, however, new geophysical and geological data led ETH geophysicist Eddie Kissling and Fritz Schlunecker, a sediment specialist from the University of Bern, to express doubts about his theory in light of the new information. The researchers postulated an alternative mechanism for the formation of the Alps. So, we could actually read a bit of that. Kissling and Schlunecker pointed out that the topography and attitude of the Alps have barely changed over the past 30 million years, and yet the trench in the side of the Swiss plateau has continued to sink and the basin extended further north. This leads the researchers to believe that the formation of the Central Alps and the sinking trench are not connected as previously assumed. They argue that if the Alps and the trench indeed had formed from the impact of two plates pressing together, there would be clear indications that the Alps were steadily growing. That's because, based on the earlier understanding of how the Alps were formed, the collision of the plates, the formation of the trench, and the height of the mountain range are all linked. Furthermore, seismicity observed during the past 40 years within the Swiss Alps and their northern foreland clearly documents extension across the mountain ranges rather than the compression expected for the bulldozing Adria model. So, no, sorry for that. Anyway, somehow, to me, it makes much more sense if we would think that the Alps have been created like probably 12,000 years ago. In kind of a similar way like how the sun is happening, but on Earth it's, of course, it's different because it's not a star, it's a planet. We have different kind of chemical environments and stuff, you know. It's different. But our magnetosphere is weakening, all these kind of things. And those ground-to-ground discharge events like big arcs, which then imply energy into the middle and on both ends, could be really well possible. But I leave it here. I maybe should have write something down before I start to make a video. But anyway, you can watch the picture or whatever. Thanks. Bye.